After you've followed the instructions to set up your workspace for this course, it helps to orient yourself with VS Code. So in this tutorial, we'll take a look at Visual Studio Code, which is a free text editor, or we often call an integrated development environment, or IDE, because many different tools are integrated together for working with our programming language, Python. So I want to walk you through some of what I think are the most important things to know about Visual Studio Code as we're getting into the course. So first, if you open VS Code and you don't see any of your files, don't fret. Typically, you'll have to go to File and then Open Recent and then look for your workspace, which is going to be named Comp11021S workspace. It's probably the last thing you had open. After you open that, if you still don't see anything, know that most of what you're going to need is found in the sidebar here. So the File Explorer is how you can browse the directories or the folders and the Python files of your project. We'll try making a very simple Python file here in just a moment and looking at how we might evaluate it. Okay, just for reference sake and to prove to you that these are just files on your computer that you can access outside of VS Code as well. You can right click on a file, and if you were to say reveal in File Explorer on Windows or reveal in Finder on Mac, you'll see that these are just folders and files on your computer. There's nothing that special about them. You can toggle these panes. There's a way of searching for things in your files. We'll sometimes use this source code when you're trying to back up your work, and there will be instructions for how to do that. We're not going to worry about that here. As we get into more complex programs, we'll see that Visual Studio Code has some really nice debugging characteristics so that we can, or tools, so that we can run our programs in sort of in a matrix mode, like pause our program, inspect what's happening at a given point, and force it to work step by step rather than all at once. You've already seen some extensions to get the expected and desired extensions installed. We're using the One Monokai theme this semester, which is a beautiful theme for working with Python files. And later we'll look at how we can use this testing pane in order to run tests in our project and what that means, but that's beyond our concern right now. Down in the bottom of the status bar, you should see Python 3.9 as your selected Python interpreter. If you don't see that, you can click on it and hopefully select it. And one of the things that we will commonly be using in this course is the terminal. So if we open up a new terminal, after you've followed the instructions on Mac, you'll see ZHS here. And on Windows, if you see PowerShell, try going back through the instructions and giving it one more go for setting bash as your default interpreter. You may see something slightly different here, like your name or something about your computer. I've simplified mine down to just be this $sign, but this is a shell. As we mentioned in the earlier lesson, this is where we can give textual commands to run our programs. So I'm actually going to increase the font size of mine quite a bit. And I want to show you how I can run Python in an interactive mode. So the Python interpreter, after you've set up your computer, should be available with the word Python. And I can check the version of it just to be sure. 3.9, great. And from here, if I want to actually start the Python interpreter, so I can just run the program Python, and this is the name of the program that we're running, and I press enter, you'll notice that now my prompt looks a little bit different. I've got these 3 greater than symbols. What this means is I'm now writing code in a Python process. So I've begun a new process. There's an invisible app running behind the scenes that I can interact with through my terminal by typing into it. As I write an instruction, it's going to be read. If I have some bad syntax, we'll see that there's errors that might occur. We'll look at what more of these errors might be in due time. But if it were an instruction that it could understand, it will evaluate it. So let's try writing a very simple instruction. One of the built-in functions, if you remember, there's these built-ins, is this help function. So help is defined as a word that we can use. And if we were to use this help function, like help me with the absolute value function, it tells us that, hey, there's this absolute value function. We need to give it some value for x, and it will return the absolute value of some argument, right? We can also ask for help with, say, the print function. And print is a built-in function that prints, and what by print, it's kind of confusing. It actually means that And there's more than we need to know for what print is. We don't know about flushing and some other things. But print just means cause this information to be displayed as output when my program runs. So let's try printing, and let's just do a classic first program, print hello world, right? And so as soon as I press enter, notice that the interpreter read what I wrote. This is a statement in the Python programming language. We'll learn all about what this means in due time. So don't stress if this feels like a lot of different little symbols and things like that. And it evaluated it. And so the print function causes output to show up on the screen. And this is just what we call a simple piece of textual data. In Python, this will be known as a string. We'll talk about strings quite a bit and use them because we use text in our data all the time. All right. So as another example, we can do something like print 3 plus 3, and that evaluates to 6. So we've got some ability to form what are called expressions, and those expressions will be evaluated when our instruction is evaluated. And then print is, of course, going to display the result. We can also do things like define certain values. So we'll talk about what it means to have variables and to define variables very soon. But let's imagine that we're defining a variable named quiz, and let's say that it's an integer type. So quiz : integer is saying that the name quiz is going to be of type integer, meaning we can store numbers in this, we can bind numbers to this name quiz, and we can assign 100 to it, right? Because we're going to have perfect quiz scores. Well, now what we've just done is we've introduced the name quiz into our program. And so in memory, in that globals frame that we just looked at, the name quiz would now have the meaning 100 associated with it. So if we were to print out, well, what is quiz? Notice it's 100. But if we were to print out, well, what is our final exam grade? Right? Final is not defined yet. We haven't associated any meaning with the word final. We'll learn all about what it means to declare variables and how we think about those being in memory. But hopefully this can start to connect the idea that we just talked about in our programs are going to sort of start to define some concepts and then operate in little algorithms in terms of those concepts. And we can do some really exciting things once we have just a few more ideas under our belts. But we'll get to those as they come. As I mentioned to you, in an interpreted, we're programming in an interactive fashion here. So when we quit this process, any memory that we had associated with, say, that word quiz is reclaimed. It was ephemeral. It goes away. So that process just ended. And if I were to start another Python process, that meaning of the word quiz is no longer defined, right? It only existed because we were running the prior interactive REPL, which is another name that you'll hear for the interpreter when we're working with it interactively. You'll hear it called a REPL, and we'll talk more about REPL later on. And anything that we defined previously, if we quit out of it, it's not going to be there when we come back to it. So the one other modality that I mentioned is the idea of a stored program. And I just want to give you one quick example of how that might work. So in VSCode, if I were to go to lessons and make a new lesson for 00 stored program.py, and I'm just going to add one single instruction here. Let me make this so that it goes a little bit more. So I right-clicked on lessons, did new file, and now I'm going to type into this file, which is going to be a Python program. One of the things that we will get in the habit of is adding a note or some notes to the top of our file that describe what it's all about. And this is an example simple program, right? And those three quotations, we'll talk about exactly what they mean. Treat them as magical incantations. This is syntax for now. And we need them on both sides of that first line. So this is just describing what the program is, and all it's going to do is let's do what we did before. So quiz is an integer, and it's assigned 100, and we can print quiz, right? So we haven't done anything exciting in this program. We can also maybe say print hello world first. All right. And maybe also print goodbye, to get a sense that we can add multiple statements here. So notice there's 4 statements, one after the other. First, we're printing hello world. Then what we'll learn is defining a variable named quiz, assigning it a value of 100. Then we're printing out whatever quiz is defined as. So we just invented this word quiz and we gave it a value of 100. And then we're printing goodbye, right? So what we've done is we've written a recipe. Now, when we're working in this modality where you're writing a Python program in a .py file, your computer isn't acting on this immediately. This is a lot like writing a recipe down on a piece of paper. Nothing happens until you go and follow the instructions. So how do we get our computer to follow these instructions? Well, what we're going to do is open up a terminal. And one of the things that you should know is if your terminal has a lot of output in it, you want to get rid of it, that trash can can start you afresh, right? So in my terminal, I'm once again going to use the Python program. So in the previous steps, we set up Python to be linked to the Python interpreter for Python 3.9, right? So previously we started Python directly and just used it interactively. Here we're going to say, hey, Python, I want you to run this stored program. The way for doing this is requires one extra step. We have to use what's called a flag here. So -m means, hey, I want you to run this program as a module. We've got a lot more vocabulary and terminology to learn about, so don't stress this idea of what a module is or isn't. We'll talk all about that in the coming weeks. But this -m means I'm about to ask you to run a particular file. And because this file is in the lessons directory, so lessons is where this program was stored. And the name of it is 00 underscore stored program. I'm going to say lessons dot and then 00 underscore stored underscore program. So notice this corresponds to the name of the directory or the folder, and then the name of the Python file, but I'm not including that .py. And when I press enter, notice that what happens is, and one of these lines is scrolling off my screen. Let me try this, running this one more time. When you're working in the terminal, if you use the up arrow, you can very easily go back to previous commands that you ran. So I just pressed the up arrow and that gives me what I just evaluated. And oh, I guess there were only supposed to be 3 lines, right? Because the 4th line here, where we declared the variable quiz, doesn't have any visible output, right? We didn't print that. We just, in the context of our running program, set up the word quiz to mean 100. But notice that when we asked Python to interpret this program, it carried out all 4 of those instructions, one after the other after the other. So one of the things that we'll see is common and as a pattern as we're writing programs is the interpreter will start at the top. It will look at the next chunk of code, which in this case, we're seeing statements which are single lines. It says, okay, is this a valid line of code? Do I know what it means? Do I know what the print function is? Well, yeah, that was one of the built-ins. And we'll learn about what strings are and integers in the next set of lessons. And it carries out, it evaluates each one of these steps one after the other after the other. We'll learn much more interesting ways of making our program responsive in just a moment, or as the semester continues on. But these are some of the fundamentals to get used to. And as we get into some of the tutorials that you'll be reading, when we're talking about working at an interactive REPL, that stands for read, evaluate, print loop. That is simply running the Python program directly. And here we're typing our code in, but everything we do within this interactive session goes away when we're done with it, right? So as soon as we quit out of this, any variables we declared or anything we've done is lost. And because for the most part, we'll be writing programs that we want to be able to come back to later or run many times with different inputs and things like that, we'll tend to write our programs in stored programs. This should be all you need in order to get started with the first exercise, which is a hello world exercise and includes some of these ideas, as well as the upcoming readings, which are tutorials on a little bit more about data types, such as integers, and I mentioned textual data, as well as some of what we call expressions. And that's how we start to take things like formulas or other more complex ideas and use them in our program successfully. Great work today.